Hello everyone, my name is Karan Mashru. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is number of subarrays with maximum value in given range. First of all, let us start by looking at the question. What does question say? Given an array of n elements and L and R, print the number of subarrays such that the value of the maximum array element in that subarray is at least L and at most R. So basically we have an array of n elements and we want to find the number of subarrays in which the maximum value of that subarray is between L and R. Okay, so if we look at this example, so here there are 4 subarrays where maximum value of that subarray is between 1 and 10, including 1 and 10. So one subarray is 2 is between 1 and 10, another subarray is 2 0, the maximum value in 2 0 is 2, which is between 1 and 10. Another subarray is 3 where 3 is between 1 and 10. Another subarray is 3 0 where the maximum value of this subarray is 3, which is again between 1 and 10. So the number of such subarrays where the maximum value of that subarray is between L and R is 4. Okay, similarly you can have a look at this example. This is a function problem. The input is already taken care of by the driver code. You only need to complete the function count subarrays that takes an array ARR, size of array n, element L and integer R, and return the number of subarray with maximum value in range L to R. The driver code takes care of the printing. The expected time complexity is big O of n and expected auxiliary space is constant. So if we think about solving this problem, then here we need to tell the number of subarrays. So let's say there are n elements in the array. Okay, let's say for this example there is n equals to 5. So what is the total number of subarrays? The total number of subarrays is n into n plus 1 divided by 2. So in this case it would be 15. Now out of all these subarrays, I need to return the number of subarrays where the maximum value of that subarray is between L and R, means it is between 1 and 10 included. Okay, so the maximum value of a subarray is between 1 and 10. I need to return such subarrays. So now tell me, can I have any such subarray in which any element is greater than R? No, because even if it is not maximum element, or even if it is maximum element, if the element is greater than R, then the maximum element of that subarray will also be greater than R, right? So those subarrays will not be included. Also, I do not want the subarrays where the maximum value is less than L, right? I want the subarrays where the maximum value is between L and R. It means that I cannot have any element which is greater than R, but I can have elements which is less than L given there is at least one element between L to R and no element greater than R. Okay, so now what is the easier way to do this? So what I can do is I can count the number of subarrays where values are less than equal to R minus number of subarrays where values are less than equal to L. See, if I calculate the number of subarrays when values are less than equal to R, then I will have such subarrays where all the values will be less than equal to R, and so here I am trying to calculate the number of subarrays where, okay, just a second, this will not be less than equal to, this will be less than L. Okay, so here I will calculate the number of subarrays where the maximum value is less than equal to R. So this will return me all the subarrays, the number of subarrays in which the values are less than equal to R. So the maximum value is less than equal to R means it can be even less than L. But such subarrays I do not want. So if I subtract the number of such subarrays where maximum value is less than L, means the maximum value is up till L minus 1. Then the remaining answer would be the number of subarrays in which the maximum value is from L to R. Remember, it can contain values smaller than L, okay? But the maximum value in that subarray should be between L and R. Now, how can I calculate these values? So this is very easy. So if I want to calculate the number of subarrays with values less than equal to R, let us take this example. So I have 2, 0, 11, 3, 0, okay? And I want to calculate the number of subarrays where values are less than equal to N. So I will take a left pointer equals to 0 and right pointer equals to 0. And I will keep incrementing my right pointer until the values are less than equal to 10. So R is 2. So 2 is less than equal to 10. So my R will come here. Now 0 is less than equal to 10. Yes. So my R will come here. Now 11 is less than equal to 10. No. It means this is not a valid member to add in the subarrays counting of this. Means I started from L and I ended at R. So from L to R minus 1, all the elements are less than equal to R. From L to R minus 1, all the elements are less than equal to R. So the number of subarrays from L to R minus 1 will be added to my count of subarrays where value is less than equal to R. So the number of subarrays from 0 to 1 is how much? 3. This alone element, and this both together. Okay. 2, 0 and 2, 0. In general, how can I calculate? If I want to calculate the number of subarrays between L and R minus 1, the total number of elements between L and R minus 1 is how much? R minus 1 minus L plus 1, that is R minus L. And if the number of elements in this subarray is R minus L from L to R minus 1, then the number of subarrays will be J into J plus 1 divided by 2. Okay. So I'll calculate the number of subarrays which can be formed here, because here all the elements are less than equal to R, and add it to my answer. Then this was the point where the element is greater than R. So I will move my starting pointer to here. Okay, L equals to R plus 1, and also move my R here. Now again, this is equal to R, less than equal to R. 3 is less than equal to 10. Yes. So my R will go here. 0 is less than equal to 10. Yes. So my R will come here. Now I come outside of the array. So my L finally is how much? It is pointing to 3. So it is equal to 3. Like this index is also 3. Okay. 0, 1, 2, 3. And my R is equals to 5. It has come outside. So from 3 to 4, I need to count the number of subarrays, because these contains the values less than equal to R. So from 3 to 4, there are 2 elements. So again, there will be 3 subarrays. 3 alone, 0 alone, and 3, 0. So again, 3 subarrays. Here also there were 3 subarrays whose value was less than equal to R. Here also there are 3 subarrays whose value is less than equal to R. So this became equal to 6. Now I want to calculate the number of subarrays with values less than 6. So I repeat the same process, but now instead of less than equal to R, I include the elements in the subarray where values are less than L. Okay. So it is 2, 0, 11, 3, 0, and value of L is 1. So my L is here and R is here. 2 is less than 1? No, it should be less than 1. Okay. L is 1. So my L will go here and R will also go here. 0 is less than 1. Yes. So my R will go here. Now this is less than 1. No. So my L value is 1 and R value is 2. So I want to count the number of subarrays from L to R minus 1. That is from 1 to 1. That is nothing but 1. So there is one subarray which contains where maximum value is less than L. This is the alone subarray. Similarly, when I'll move forwards, I will get one more subarray where value is less than 1. Okay. So there will be 2 such subarrays. So 6 minus 2, the number of subarrays where the maximum value is between L and R will be 4. Now let's look at its actual implementation. So if I look at the actual implementation, so I have array A, number of elements in the array, and L and R given in the input. I have taken L and R 0 because I want to traverse the array and count the number of subarrays, and I have taken some variables. Initially answer equals to 0, and I have taken 2 variables S1 and S2, but basically I have not used S1 and S2. Okay, so look here. So let's start from here. What I have done here is I have counted the number of subarrays where the maximum value is less than equal to R. So initially L is 0 and R is 0. If the value of A of R is less than equal to R, do R plus plus. Else, number of subarrays, number of elements from L to R minus 1 is J, that is equals to R minus L, and the number of subarrays between L to R minus 1 will be J into J plus 1 by 2. So this will be the number of subarrays. So when I get an element greater than R, I first calculate the number of subarrays which can be formed from L to R minus 1 where value is less than equal to R, and add it to my answer and do L equals to R plus 1 and R plus plus, and then again repeat the process. Also, after I come out of the loop, I again calculate J equals to R minus L and answer equals to answer plus this. Why? Because as we saw in the last example, if we have, like if we look here, so finally when we came out of the loop, my L was pointing here and R was here. So the subarrays due to this needed to be added to the answer. Okay. So I add it to the answer. So this portion will give me the count of the subarrays in which the maximum element is less than equal to R. And this portion, this is the same portion as this. You see L equals to 0, R equals to 0, 2, and everything is same, just two changes. Here A of R is less than L, then I do R plus plus. So here I'll get the count of subarrays where the maximum value is less than L, and I need to subtract that count. So here also there is subtract sign and here also there is subtract sign. So here I subtract the count of subarrays where value is less than, maximum value is less than L, and here I add the count of subarrays where maximum value is less than equal to R. So their difference gives me the count of subarrays where the maximum value is between L and R, and finally I return the answer. What is the time complexity? I am using two for loops, so time complexity is big O of n, and what is the auxiliary space? It is constant. Okay, now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.